Hello, grade 8. Welcome to another lesson. Today, it's going to be a short lesson. Going through a few examples, and we're talking about volume of cylinders. Now, previously, we've done volume. If you remember, the volume of prisms, any prism, V, I'm going to put VP for volume of prisms. It is equal to the area of the base. It will be B multiplied by the height. That is the volume of any prism, where B is the area of base. So it is very similar for volume of cylinder. Cylinder kind of looks like a prism, but it doesn't have a base of a polygon. It has a base of a circle. So the volume of cylinder, V of C, volume of cylinder, is actually the same. It is the area of the base multiplied by the height. That is also area of base. The only thing that is different about a cylinder is that the area of the base, so I'm going to put the base over here for the cylinder. This B over here is equal to pi times r squared, the area of a circle. Because the base of a cylinder is a circle, and so the base of the cylinder will be pi times r squared, okay, where the square only applies to the r. So that means the volume of the cylinder is equal to pi r squared times h. That is the volume of a cylinder. That will be volume of cylinder. Now, let's go into an example straight away. It's kind of simple. We have a cylinder over here. And it has a diameter, this time. The diameter, D diameter, is 6 centimeters. And let's say that the height is 10 centimeters. So we're told to find the volume. Find the volume. And so how do we find the volume? Well, V is equal to pi times r times squared times h. And then r, the radius, if the diameter is 6, radius is equal to 6 divided by 2, which is 3 centimeters, which means that the volume is equal to 3.14 times 3 squared times 10. So that will be equal to 3.14 times 9. Multiply that by 10, we have 282.6 centimeter cubed. Remember, volume always has a unit of cubic, okay? Because it's cubed. Volume is just cubed. Just remember that. Now let's look at another example. So this was example 1. Example 1, finding volumes of cylinder. Now, for example 2, we're going to find the height of a cylinder given the volume. So let's try to be a little bit more specific in this one. So let's say that a drinks company is making or designing a new aluminum can. Aluminum, that's correct. Aluminum can for a drink. The volume of the can must be 330 milliliters and the diameter of the can is 4 centimeters. So they want it to be quite thin. What should be the height of the can. So we have a diameter of 4 centimeters. The volume is 330 milliliter, which means that the volume 330 milliliters is the same as cm cubed. You can say it's similar. Okay, I'll just use cm cubed to be consistent here. Centimeter cubed. And so what should be the diameter of the what should be the height of the can? So first we know that the volume is equal to pi times r squared times the height. What are we given? We're given a diameter of 4 centimeters. So radius is equal to 4 divided by 2, which is 2 centimeters. We can work that out in our minds. And then now we have all the necessary information to find the height. So what we're going to do is we're going to plug in 330 is equal to 3.14 times 2 squared, which is 4, times the height, which means the height, we're going to do 3.14 times 4. That's going to be 12.56 h. That's equal to 330. That means that height is equal to 330 divided by 12.56, which will give us a height of 330 divided by 12.56 is 26.27 centimeters tall. So that's not a very that's a super tall can. That probably looks like this with a new drink. Maybe that's too high, and so maybe they should change the diameter. I should change the diameter to maybe 6 centimeters or something. But that's maybe it's a little bit too tall for a can. But that's just an example, okay? So now the last type of example that we're going to do is finding the radius. Okay, so we have example 2, now we have example 3. Let me just type it. So example 3 will be finding the radius of the cylinder once we're given the volume and also the height. So let's say, for example, a barrel has a volume of 1, or let's say it's volume of 3 cubic meter. No, 2 cubic meters. Let's just say 2 meter cube. I'm just making up these numbers, okay? And so if the height of the barrel is 1.5 meters tall, what should be the diameter of the barrel? Now remember, most of these questions I'm asking the diameter, which means we're gonna have to convert from diameter to radius all the time. So the barrel has a volume of 2 cubic meters, and then the height of the barrel is 1.5 meters tall. What should be the diameter of the barrel? So first of all, V is equal to pi times r squared times h. And so the volume, we're going to put in all the information that we have. 2 is equal to 3.14 times the unknown radius squared times the height of 1.5. So I'm going to multiply 3.14 by 1.5. That's going to give me 4.71. So 2 is equal to 4.71 r squared. And then once I divide 2 by 4.71, 2 divided by 4.71, we have r squared is equal to 0.42. 42, I'll just leave it at 2 decimal places. And then now what I have to do is I have to take the square root of both sides because this is r squared. And so to get rid of the r squared, we take the square roots. And so that means that r is equal to square root of 0.42 would give you 0.65 meters. So the radius So the radius is equal to 0.65 meters, which means that the diameter is, multiply that by 2, 0.65 times 2 will give you 1.3 meters. We have a diameter of 1.3 meters. So we're able to find radius when we're given the volume and also the height. Okay, so that's pretty much it for this lesson. For your homework, we're gonna go through more exercises afterwards, but for your homework today, please do exercise 12.6, and then questions 3, 5, 7. Let's also do 9, and then we have 11, and then let's do some interesting questions as well. Let's do 16. Actually, I'll leave that for next lesson. Let's do 15 first, and then that one problem solving question. So let's do 22, and that's it. Next lesson we'll do a little bit more questions. So today it's only going to be 1, 2, 3, 4, 5, 6, 7 questions for homework, and then next lesson we'll do more questions. That's it for today's lesson, and I will see you in our next Zoom lesson.